Flammable and toxic fluids in oil and gas processing, managing hazards in energy industry fluid operations. Introduction to hazards and safety measures, objectives of the presentation. Oil and gas processing involves handling a wide range of fluids, many of which are flammable or toxic. These substances pose significant risks to personnel, equipment, and the environment if not managed properly. Flammable fluids can ignite under certain conditions, leading to fires or explosions, while toxic fluids can cause severe health effects through inhalation, ingestion, or skin contact. Understanding these hazards is critical for ensuring operational safety and compliance with industry standards. This presentation will provide a comprehensive overview of these fluids, their properties, associated risks, and the measures required to mitigate these dangers. It will also include real-world case studies to illustrate the consequences of inadequate safety practices and highlight best practices for prevention and response. The primary objectives of this presentation are to: Number 1, define and explain the characteristics of flammable and toxic fluids commonly encountered in oil and gas processing. Number 2, identify the hazards associated with these substances, including fire, explosion, and health risks. Number 3, discuss detection and monitoring systems that help prevent accidents. Number 4, outline safety measures and emergency response procedures. Number 5, review regulatory standards governing the handling of these fluids. And number 6, analyze real incident examples such as Piper Alpha and Texas City to extract lessons learned. By the end of this session, participants should have a clear understanding of the risks and the strategies to manage them effectively. Brief on upstream, midstream, and downstream operations. Oil and gas processing encompasses three main sectors: upstream, midstream, and downstream. Upstream operations involve exploration and production, where crude oil and natural gas are extracted from reservoirs. Midstream focuses on transportation and storage, including pipelines and terminals that move hydrocarbons to processing facilities. Downstream operations include refining and petrochemical processes that convert raw hydrocarbons into usable products such as fuels and lubricants. Each stage involves handling fluids that may be flammable or toxic, requiring stringent safety protocols. Understanding these processes provides context for where and how hazardous fluids are encountered, and why comprehensive risk management is essential throughout the value chain. Definition and characteristics of flammable fluids. Common flammable fluids in oil gas. Flammable fluids are substances that can ignite and burn when exposed to an ignition source under normal operating conditions. Their volatility, flash point, and vapor pressure determine their flammability. Common examples in oil and gas include methane, propane, butane, and crude oil. These fluids are often stored and transported under pressure, which increases the risk of leaks and vapor formation. Ignition sources such as static electricity, hot surfaces, or open flames can trigger fires or explosions. Understanding these properties is crucial for designing safe systems and implementing preventive measures like grounding, bonding, and proper ventilation. The most common flammable fluids in oil and gas operations include methane, natural gas, propane, butane, and various liquid hydrocarbons found in crude oil. Methane is highly flammable and widely used as a fuel source, while propane and butane are common in liquefied petroleum gas, LPG. Crude oil contains a mixture of hydrocarbons with varying flash points, making it a significant fire hazard during storage and transport. Each of these fluids requires specific handling procedures to minimize risks, such as maintaining appropriate temperature and pressure conditions and using explosion-proof equipment in hazardous areas. Definition and characteristics of toxic fluids. Common toxic fluids in oil gas. Toxic fluids are substances that can cause harm to human health through inhalation, ingestion, or skin contact. In oil and gas processing, these fluids often include gases and liquids that contain hazardous chemicals. Their toxicity depends on concentration, exposure duration, and route of entry. Hydrogen sulfide or H2S, benzene, and methanol are common examples. H2S is particularly dangerous because it is highly toxic and can be fatal even at low concentrations. Benzene is a known carcinogen, and methanol can cause blindness or death if ingested. Proper identification, monitoring, and protective measures are essential to prevent exposure and ensure worker safety. Hydrogen sulfide or H2S is one of the most hazardous toxic gases encountered in oil and gas operations, often present in sour crude and natural gas. Benzene, found in crude oil and refined products, poses long-term health risks including cancer. Methanol, used in gas dehydration and as an antifreeze agent, is highly toxic if ingested or absorbed through the skin. These substances require continuous monitoring using gas detectors, strict adherence to exposure limits, and the use of personal protective equipment or PPE such as respirators and chemical-resistant clothing. Hazards of flammable and toxic fluids, detection and monitoring systems. Flammable fluids pose risks of fire and explosion, which can result in catastrophic damage to facilities and loss of life. Toxic fluids present health hazards ranging from respiratory distress to long-term illnesses such as cancer. Combined hazards occur when a substance is both flammable and toxic, such as certain volatile organic compounds. These risks necessitate robust safety systems, including hazard identification, risk assessment, and implementation of engineering and administrative controls. Failure to manage these hazards can lead to incidents with severe consequences for personnel and the environment. Detection systems are critical for early identification of leaks or hazardous concentrations. Gas detectors, both fixed and portable, are widely used to monitor flammable and toxic gases. These devices often integrate with SCADA systems for real-time alerts and automated shutdowns. Alarm systems provide audible and visual warnings to prompt immediate action. Advanced technologies include infrared sensors for hydrocarbon detection and electrochemical sensors for toxic gases like H2S. Regular calibration and maintenance of these systems are essential to ensure reliability and accuracy. Safety measures for flammable and toxic fluids, emergency response procedures. Safety measures include proper storage in approved containers, grounding and bonding to prevent static discharge, and adequate ventilation to disperse vapors. For toxic fluids, measures include containment systems to prevent spills, use of respiratory protection, and implementation of exposure limits. Engineering controls such as double-walled tanks and automated shutoff valves further reduce risks. Administrative controls like training, signage, and permit-to-work systems complement these measures to ensure comprehensive protection. Emergency response involves immediate actions to protect life and property during incidents. Procedures include evacuation plans, firefighting using appropriate extinguishing agents, and spill containment strategies. Specialized teams equipped with self-contained breathing apparatus, SCBA, and chemical-resistant suits handle toxic releases. Coordination with local emergency services and adherence to incident command systems ensure effective response. Regular drills and scenario-based training enhance preparedness and minimize response time during actual emergencies. Piper Alpha and Texas City incidents. The Piper Alpha disaster in 1988 resulted from a gas leak and subsequent explosions on a North Sea platform, killing 167 people. Investigations revealed inadequate maintenance and poor emergency response planning. The Texas City refinery explosion in 2005 killed 15 workers and injured over 170, caused by a hydrocarbon vapor cloud igniting during startup. Both incidents underscore the importance of rigorous safety systems, hazard awareness, and emergency preparedness. Lessons learned include the need for strict adherence to operating procedures, continuous monitoring, and fostering a strong safety culture. Personal protective equipment and engineering controls, regulatory standards and compliance. PPE is the last line of defense against exposure to hazardous fluids. For flammable environments, flame-resistant clothing and anti-static footwear are essential. For toxic exposures, respirators, SCBA, and chemical-resistant gloves and suits provide protection. Engineering controls such as ventilation systems, gas-tight enclosures, and automated shutdown mechanisms complement PPE to minimize risks. Proper selection, maintenance, and training on PPE use are critical for effectiveness. Regulatory frameworks such as OSHA, API, and NFPA provide guidelines for handling flammable and toxic fluids. These standards cover design, operation, and maintenance requirements to ensure safety. Compliance involves regular audits, documentation, and adherence to best practices. Failure to comply can result in legal penalties, financial losses, and reputational damage. Organizations must integrate these standards into their safety management systems to achieve continuous improvement and risk reduction. Key takeaways and best practices. Flammable and toxic fluids in oil and gas processing present significant hazards that require proactive management. Key takeaways include understanding fluid properties, implementing robust detection systems, applying engineering and administrative controls, and ensuring compliance with regulatory standards. Emergency preparedness and continuous training are essential to minimize risks. A strong safety culture supported by leadership commitment and employee engagement is the foundation for preventing incidents and protecting lives.